Welcome back to Sustainability Ventures, where we look beyond green headlines and examine the full environmental story. Clean technologies are often presented as emissions-free solutions: solar panels, wind turbines, electric vehicles, batteries. But here's the question we rarely ask honestly. What is the environmental cost of manufacturing clean technology? This is not anti-renewables. This is not climate denial. It's about life cycle thinking, understanding where materials come from, how they're made, and what trade-offs we're accepting. Let's follow the supply chain. Every clean technology begins in some of the dirtiest industries on Earth. To build wind turbines, steel, concrete, rare earth magnets, solar panels, high-purity silicon, aluminum, glass, EVs, lithium, nickel, cobalt, and copper. These materials come from industries that are energy-intensive, fossil fuel-dependent, and difficult to decarbonize. Steel, cement, and aluminum alone account for roughly a quarter of global industrial CO2 emissions. So before clean tech ever reduces emissions, it inherits emissions from heavy manufacturing. Clean technology is material hungry, much more than fossil fuel systems. A single electric vehicle requires several times more minerals than a conventional car. Large quantities of lithium, cobalt, nickel, and copper. Mining these materials means land disturbance, habitat loss, water depletion, and chemical pollution. In arid regions, lithium extraction competes directly with local water supplies. In some mining regions, weak regulation magnifies environmental and social damage. The transition to clean energy doesn't eliminate extraction, it intensifies it. Batteries are the backbone of electrification and one of its largest environmental costs. Battery manufacturing involves energy-intensive material processing, high-temperature refining, and complex chemical reactions. The carbon footprint of a battery depends heavily on where it's made and how the electricity is generated. If batteries are manufactured using coal-heavy grids, their upfront emissions can be substantial. This means some electric vehicles start life with a larger carbon footprint than conventional cars, only paying it back over time through cleaner operation. Solar panels produce electricity without emissions once installed, but manufacturing them requires ultra-pure silicon, high-temperature furnaces, and significant electricity input. Much of the world's polysilicon production occurs in regions with carbon-intensive power. As a result, solar panels have an embedded carbon footprint, and payback periods vary by location and manufacturing source. Again, clean doesn't mean impact-free. It means lower impact over time. Wind power seems simple, spinning blades and clean electricity, but modern turbines rely on rare earth elements for high-efficiency magnets. Processing these materials involves toxic waste, acid leaching, and radioactive byproducts. Rare earth refining is environmentally challenging, which is why it's concentrated in a few regions globally. The environmental burden exists, it's just geographically distant from where the clean electricity is used. Clean technologies shift emissions in time and space. They reduce emissions during operation, but increase emissions during manufacturing. The real metric is life cycle emissions. How much CO2 over the entire lifespan? Most clean technologies still outperform fossil systems long term, but the climate benefit depends on grid cleanliness, technology lifespan, and utilization rates. If devices are replaced too quickly, the environmental payback shrinks. Clean technology is essential, but it is not environmentally free. The real sustainability challenge is not choosing green products, it's redesigning the industrial system that produces them. That means decarbonizing heavy industry, improving material efficiency, designing for durability and repair, and being honest about trade-offs. If this video expanded your perspective, hit like, subscribe, and join the discussion. Should climate policy focus more on cleaning up manufacturing, not just deploying clean tech? Thanks for watching. And remember, sustainability starts long before the switch is